something like that? So thank you all for coming. It was quite a bit of work in the making, so for me, emotionally today, it's quite important. And I hope that the excitement will be something we share today. Now, I have a bad news to start, which is that I'm going to speak for 45 minutes before you see the demo. So let's just make it clear right away, then we have the right expectation on both sides, and hopefully the next 45 minutes are not that painful. And it's good that we start with expectation, because there are many things which, for me, are very important that we bring to you this afternoon in regard of what is data science, why should you care, how it looks like, what it can do, what are the applications, and all of the business problematic of how to actually apply it in your business in a profitable way. And to some degree, I understand that this is the expectation you have that you have to fulfill. And I have also something which I would like to achieve this afternoon. And I'd like to start just by explaining what that is. And what I would like to do is to change your expectation about data science. Now, that might sound a bit weird, especially for a lot of you who said, well, I don't really have much expectation about data science, I don't really know what that is. But that's not necessarily such a bad way to phrase it, because very often we have the worst type of expectation about the things we least understand. And we will go into that part quite rapidly now after the introduction of the events from Google last year, to try to just take a little bit of a moment to think about what was wrong in what companies were expecting from AI until recently, and what has to be changed in that expectation that businesses, e-commerce sites in particular, can take the full benefit of the real potential of data science. And for me, and you can tell me after the afternoon how much we have succeeded or failed in that goal, that's my personal goal. I'd like to change this expectation. Now, let's start with Google. So as Michael mentioned, what Google is doing actually for almost the last 10 years, actually the last 8 years exactly, in the cloud platform is quite impressive. And that's not specific to last year, but it's been incrementally growing in a quite tremendous pace. Now, of course, it helps when you have the resources of Google to do that, which of course is true. And what's interesting is that throughout the board, all of the new technologies that Google are bringing out are adopted much faster by SMEs than by large corporations. And that's very interesting because it's not intuitive. It's not self-evident that the state-of-the-art technologies, which are really in the best shape, like we will see with what Google is offering, is actually adoptable very quickly by SMEs. Usually we have the other perspective to say, okay, well, that's for the big guys, and we don't have the resources. Well, actually, what Google changes, and Google is not the only one, but it's one of the main players, what Google changes with the Google Cloud is nothing else than actually making the best technologies that exist available at cost, which are so low that every company can start to use them. Now, we will go into the details of how to do it because it's not that easy, but the potential is there, the infrastructure is there, and it is insanely affordable. Now, what happens more specifically last year, and we'll see after why that matters, is that Google released BigQuery ML. And it's the first time, I mean, machine learning, since my studies in the ETH in Switzerland and Carnegie Mellon in the US, the idea that it is possible to do machine learning without programming a line of code, but just by configuring a query, is something which even now looks a little bit unrealistic, like pure science fiction. And yet, they have done it. Now, does it cover the full scope of everything you can do with machine learning? No. But it covers a pretty decent part. And now, we are all a query away from applied machine learning. Not even a line of code away, a query away. That's absolutely impressive. We will look after what that really means. Now I just introduced the key thing, so don't worry. Now, the other things which they changed is Data Studio. Because the field of data visualization in BI and other domain has always been a complicated one, that you have some products which are cheap, but yet when you try to integrate them with the full things, it costs an arm and a leg, and so on and so forth. And Google was completely aware of that, and they said, well, you know, yes, we have our data, our Google Analytics 360, and I'm not going to go into the details of what that is, which is quite expensive. It's about 150,000 a year to start. But each component which we provide we will make them extremely cheap as infrastructure, as technology, which is an interesting position. And they went to the moon with that, because this is the system which enables you to do visual dynamic reporting, and we will have that will be the biggest part of my demo after, and it's impressive what you can do. And that's free. That doesn't cost a dime. That's absolutely 100% free. So that's interesting, because usually SMB e-commerce, they like things which are free, but as systems in general, that's quite well adopted. And the success of Google Analytics clearly has been partially because of that fact. Of course, as usual, Google has a hidden agenda, but we will not get into that today. Today we can focus on what that means. So now, why these two things, the combination of these two things matters so much? And we will get into this, but what I'd like to highlight for now is that these two things is really what changed the game in a complete sense for data science. Now, how did we look at data science so far? And that's exactly the point I wanted to make in regards of expectations for data science. Well, pretty much until now, most of our clients, and the ones who are not yet our clients, look at data science as a black box. Now, and that's the tricky part. There is something comfortable about thinking about data science and AI as a black box. Because the first thing which is cool about a black box is not only that you cannot know what's inside, but you don't have to know. So you're shielded from that part. You can imagine whatever you want happening in that black box. And you're not responsible of what's happening in that black box because you don't even have access to what's in that black box. So there's a positive attraction towards having a black box provider to improve your website. You don't have to plan resources, you don't have to manage that complexity, you can just wait for the promise of someone to deliver the business value. Now, the problem, and that's exactly the point of what I was trying to say in terms of data science application, the problem is obvious, it cannot work. And technology, the algorithm is not the problem, it cannot work at all. Now, let's dig into that a little bit more. So here, if you take the black box principle, which a lot of people know, then what is a black box? Basically, you have an input, you have an output, you don't know what's inside. That's basically the simple definition of a black box. Now, what is likely to happen to a company with a provider which provides a black box to do AI? Well, that's going to happen. First, you have the IT, not a data engineer, because that's not even part of the discussion. You have the IT, who is responsible of feeding data into that box. Without really understanding and knowing what's going to happen in the box. Well, I mean, that's not easy. So it's like, what data should I put? How should I format them? What makes a difference? Maybe it helps if I put all my data. And it's both ways. You can put a huge amount of data in the hope that the system will use them and it doesn't. And vice versa. You cannot put the data that the system would have needed because you don't understand what the system would do with it. So that's not good. That's the first consequence. And the second thing is that, well, the output is judged by a manager typically. It's not an integrated process in your operation. So you have some kind of output which is thrown on your website, some statistics, and then the manager has to say, well, testing, it's good or bad. And it's always bad. How could it be good when you don't even know what's inside? There's no domain knowledge transfer of any kind. So it makes no sense to me. So then the question, why do I get these results? Two possible things, either no answer or a completely ununderstandable answer. And then comes the question, well, then you have to change provider. I should have a better black box provider with a better AI, or a better black box provider with a better AI. Every time it goes me an arm, I like to reintegrate the data. I still don't know what to put in it. I don't really know how this system works, but I expect results. Well, that's the problem with the current expectation of data science. So what is the data science ecosystem? Well, the idea is that your organization is heavily integrated in data science. That doesn't mean that everyone has a PhD in mathematics, not at all. but everyone is integrated at its level. So for the IT, that's how my data are used. He can see it. He can really see that's what they do with the data. Oh, that's helpful. That's really helpful. I can see how best to provide them. Then you have the analyst who can say, okay, I see that our brand campaign doesn't work on that customer segment. Well, you can say, before you can say in the back, well, that's a failure of the AI. Yeah. No, you can do something about it. You can find better matches for that segment in regards of that aspect. And you can change the content you provide based on that knowledge. Here comes to the marketer. Oh, nice. These segments responded positively to my last campaign. I can really focus on them. So the marketing activities change because of data science. It's not only that data science optimizes them, they're changing because they are instructing the marketers about that. And of course, let's not forget the manager. Great, our new brand is more promoted and profits are going up. Now you can say, well, that's very nice because here you're saying something positive and here's something negative, but it might be negative there. What's important for me is not that this is negative, this is positive. Of course, it's a little bit important. But not completely. What's important for me is that the level of detail of what the manager understands has nothing to do with that level. Because he understands why. He understands what is working better. He's not speaking about, oh, that's my global conversion rate, are we happy about it or not? No, he understands that his goal to promote their own brand, to increase the profit margin, is working for which segments and to which extent, and he can make a judgment on that, as well as many other things. So that's the big difference. Okay, so now let's go into the question, what is data science? Because now I just spoke about the way data science, the role data science should have in your organization. What is data science? And this is where it becomes problematic. Because it's not that it's badly defined. It's not that it's hard to understand. Let's go through the definition. The data science is an intersectional discipline, which is about the crossing of three domains: computer science, mathematics and statistics, domain and business knowledge. And all of this, and of course, especially the overlap of the three, is the definition of what data science is. Well, it is helpful to know that's what data science is. Now, it's not that helpful because what does that mean for the company? Do you do much mathematics and statistics? Or would you even name it? You have a department of math and statistics? No. Okay, well, you have IT guys. Yeah, okay, so okay. And you have, domain, business, we have marketers, and it's but is it marketers? So it's a proper definition, but it's not a very helpful definition to imagine what that could mean for the organization of your company. So let's try something else. Let's try to think about three different roles: core data scientist, data science analyst, and data engineer. And believe me, this is very helpful to think this way, because these are positions which you could consider as specific roles to have in your company. Now you say, oh, I don't have, wait, I don't have anyone in data science. Now you're already speaking about hiring 3 people. And of course I would say, yeah, but it's not necessarily 3 people because you can have several for each level. And of course, that could be the fear reaction of these different roles. But bear with me, there is a happy end of that story. No, let's just take a moment to think about what are these 3 roles. Core data scientist. The core data scientist, this is the PhD in mathematics guy. That's the guy who does deep learning and AI. That's the guy who thinks about statistical model and a new way to train data, which no one in your company understands at all what he's doing. That's usually what we have as an image of data science. So it exists. It's not that your image didn't exist, it's just a small part of the pyramid. The data science analyst is the person who will use maybe simple machine learning techniques, very simple, but will spend most of her time doing data analysis to understand patterns, to understand what works, to understand what are the opportunities to do A/B testing, optimization, different strategies as an analyst, and which will, of course, prepare experiments to be tested. And the third role is the data engineer, is the person who is working with the data so that they are loaded and available for analysis in the shape and form which is needed for the business and the applications. Okay? Now, there was this interesting pyramid that Michael brought up before, and he promised that we would get back to it. And we are back on it, because that's what it is. That's the core data scientist, that's the data science analyst, and that's the data engineer. So this is exactly the right way to think about data science. This is the most helpful diagram to understand data science I've ever seen. Yes, there's a lot of terms, but believe me, it's worth to take the effort to get into it. Now, for the sake of the discussion today, we're not going to go into each of these terms. That's not at all the topic. But we need to understand these differences. So the first big difference is what I explained. What's important here, of course, is that this has a lot to do with reporting. Because to some degree, as an analyst, it's not even because you need to show a report to the CEO. It's not only that you need to have a report yourself to know if there's any meaning in what you're doing. So it's an extreme reporting-oriented environment. Well, this is really just a data provision focus, and this is really a statistical AI model focus. Okay, so now my point, and there is overwhelming evidence of all of the domain for that, is that the role that matters for you is the middle one. That's where the huge amount of low-hanging fruits and not so low-hanging fruit which can be gotten relatively quickly lies. It's not on the top. You're going to say, well, that's all fine, but it's not that there's a data engineer because I want one, there's a data engineer because I need one. So what about this one? Well, we're going to get into this now. So now let's think about infrastructure and data science, because that's also a very helpful thing to think about data science differently. Think about infrastructure separately than you think about the actual activity of data science. So on the left, you have your eShop. Your eShop, your mobile app, your email system, all of these real-time or not real-time touch points with the end customer. You have this. And now we said, okay, well, what is really interesting as a role is to make a room for the data science analyst. Okay. So with that premise, how do we make it happen? Again, the story starts with all of these people, but don't worry, it ends well. So first, you want to report facts. Because as we see in all of our clients, the first thing is that many facts are completely unknown. So it's not even about finding correlation and patterns. It's about having any idea what's happening at all, except according to the total aggregated reports of analytics, which are to a large degree completely useless. Now, you can do a certain amount of things here without preparing a data source. So you can connect to data Google Analytics, you can connect to Google Sheets, you can connect to a custom SQL database, you can do these type of things. But very quickly you'll be limited in a massive way. Because the trick with data science analysis is that you need the data exactly the way that you need them so you can do your job. And that's very important that this is provided. So comes very quickly the need to say, okay, well, we need something more. And BigQuery is this more. We need something more to be able to support the reports of the facts, to start with, in Data Studio. Now, of course, BigQuery is a database. So something has to be done to fill this database. And this is where, of course, this collection, the data engineers come in. But he's still there. I know, he's still there. But with that comes the possibility to do these reports in a much more advanced way. And then to go to the next steps, which are finding patterns and causes. Good luck to do that without BigQuery, just to be clear. And then training models. Oh yeah, but we have again a problem, because when we train models, we need these core data scientists, and I don't expect that a lot of you have a smart PhD in mathematics sitting on a desk having nothing to do. So that's not really a resource which is easy to get. And then you have another problem. You need an IT engineer to integrate the experiments. And that's no picnic, depending on what experiments you're doing. So now we have a start of an idea of what that could mean, but we have all of the problems. Now, of course that's in purpose, there comes Boxalino. So, what we try to do, and what we focus on doing last year, and what is the core topic of what we're releasing today, is that CPU big data, which is heavily intertwined with the BigQuery, which automatically generates a structure and stream and collects and formats data automatically out of the box, in order to reduce the efforts there to an absolute minimum, to a large degree to a point that this is not needed. So that's the first thing. Then, second thing, which is not new by the way, but which we're always improving, we have our CPU real-time platform, based on very advanced technologies like PMML, Solar, Cassandra, all of these real-time technologies that are working at blazingly fast speed with extremely complex model in the back. And this reduced the need of the IT engineer. Now, let's be clear, I'm not saying that there's no need to integrate these aspects. What I'm saying is that it's done, and then it has nothing to do with the workflow of data science. Whatever is integrated can be optimized without intervention of IT engineers. Of course, they are needed to set up new things, new type of things. Then, last year, BigQuery and outcomes. Well, that's a big deal, as I said. Why is it a big deal? Because you don't need that guy anymore. Now, okay, yes, to do deep learning, TensorFlow, you still do, fine. But you don't need that guy anymore. That's a big deal. Because now, with one person, one role, this becomes possible. And that's the big deal. That's what's completely transformative. So, now, let's look into applications. So, a lot of you know, but some of you don't, so I will just briefly introduce it. We are customer journey focused as a company. And we have defined 6 steps in the customer journeys, which we build our framework, our infrastructure, and our features around. Awareness, which is basically when you get a new client, never bought anything, comes to your website, just arrives, you pay for the click, that's clear, but so far you only managed to create awareness. So he comes on a landing page, that can be a start page, that can be another page, and he's discovering what it is that you're offering. He has no concrete idea of exactly what you offer for him, which is good. But he's there, that's the start. Now, then he starts to browse, to make a search, to use your categories, your menus, try to see product listing pages. He starts to consider. And then he starts to look at specific products, compare them, look at what is the best deal out of different possibilities, make an evaluation in order to be able to identify something he might want to buy. And then maybe he adds some other stuff in his basket because it's a good deal, and then he actually concludes the purchase. So we have these 4 steps. And then he's registered, and then he's hopefully logged in most of the time, and he has access not only but also to his account page where you can build what we call loyalty. Because you know this person not only as a visitor, but as a customer. And this is the inbound, so you also can reach out to your customer outbound with an email, with a push notification, all of these things. So these are our 6 customer journey steps. We will try to model the customer journey optimization for each step, and of course, throughout the steps. Now, let's look at the application. So, let's start with the awareness. So, with the awareness, the way that we look at it is that, well, you should care about welcoming and promoting. At this stage, this is it. So you have probably some campaigns, some make sense for the traffic source the person is coming from, others don't. Some products which most people are interested in others not. So you can promote and you can welcome them, giving them things of a certain level of generic and segmented interests. So if we take all of the screenshots that I will show you are taken from clients of Boxalino, of things which are already integrated with the Boxalino system. But it does not really matter, because the topic today is not about showing this is the touchpoint optimizer that Boxalino can do or not. It's really to bring the questions about what should data science do about it. Once it is integrated, what should data science do about it? Well, there, of course, it starts for the data science analysts with the fact that the data have to be collected. That's for sure. Then, based on these data which are collected, some initial visualization can be done. And thanks to this visualization, the following questions can be asked. Why this campaign? Why these services? Why these products for this visitor at that moment? And of course, many other questions. And based on the findings of the data scientist, then she can create an experiment which is then integrated on the page to change the content of the page and create a perpetual process so that part of what's learned is not only if the changes work better or not, it is also what type of things people did differently in regards of the changes of the experiment to learn more about what the customers want. So that's basically for awareness. Now, for the other steps, I'll go slightly faster, but you get the idea. So this kind of circle is always there, it's just not there visually, but you get the point. So here, for instance, consideration, well, it starts when people are searching. And that's a good example, because when you search for SCH in German, man, that can mean many different things. And here, as for the wine finder, okay, well, Renzo here, this sommelier is helping you to find the right wine. Well, what are the questions then for the data science analyst? Well, why this sommelier? Why this question now? Why this score for that specific product? Or, why is chocolate first and not schmuck, for instance? And why is it schmuck first in the product and not chocolate? Or vice versa. Maybe most people are searching for one thing or the other. So that's exactly the question. So it works in awareness. It works in consideration. It works in evaluation, read and upsell. So here, we have a product page with some alternatives. We have a blog page with some related products to that theme. Well, same thing. What other question? Well, why selling this product? It's not only what should be the products here, it's also why are we selling this product at all compared to other products? I mean, what is it really good to have it? Because it's not necessarily better to have a bigger assortment. Why is that price? Shouldn't we make it higher price because we sell just the same amount with a higher profit? Or should we lower the price? Because if we don't, we will not have the volume that we want. And of course, are these the right product matching? And same thing for a blog. It's like, okay, this is about order. Now, with these tags and this, why this product, but also why to speak about Wobbler to start with? Was it a good idea to write a blog at that moment about that? And was it the right content? Purchase? Well, now that I have had this in my barn call, well, I can buy this, or in a different situation I can buy that, and I have this free gift. Well, another question. Why this cross-selling? Should it be the same brand? Why this free gift? Why this other cross-selling? So this works throughout the board. Now on the account page, well, what are the questions? Why these loyalty points? How many points each purchase should give? And what can you do with the points? Is it better to give a lot of points, but that you don't do much with it? Or is it better to not give so much point, but each point has a very strong value from the perspective of the client? Well, that's a good question for data scientists. Why hair care first? Why this product that already bought and not others for the repurchase? Why this cross-selling? Why these blog articles? And up to the emails. Okay, well, why this email alert now? Well, you can say, well, that's a search abo for the word secretary. So it's because there's some position related to being secretary, which is in. Yeah, but this is a big question for data scientists. What happens for the cases like the search abo which are triggering 50 matches per day? Do you send 50 emails? And what about the ones which only generate a match every 2 months? Do you wait 2 months until you send the next one? And of course, here in the in this type of newsletter, so why this style and why these products? So the questions is for everything the user sees at any step of the journey. Now, it's also the question for between the steps. And for between the steps, basically, we have this very common problematic. Well, we have not the conversion rate that we want. Well, it's a question, do you not have the conversion rate that you want here? Or is it caused by because many people live here, or here, or here, and in which case? So the journey itself is something to analyze. As well as, why do I have so many one-time purchasers who are not buying again and never buying? Because I'm paying X Swiss franc to acquire new clients, and if 50% of them never buys again, then that's a problem. And when I'm sending an email, what type of content should I send? To which type of person? So whether it is between the steps of customer journey or in each of the steps, the questions that are raised by data science and the applications is ubiquitous. Now, an interesting point. Very often, I see clients focusing on, oh, my competitor has this feature on the basket, we should have the same one. With the goal to have a website which is as luxuriant as possible, showing the capacities and the fundamental values as much as possible. But data science builds something different. It builds something on the ground. That's what it builds. And that's not copyable by your competitors. They cannot go to your website and say, oh, yeah, that's what they did. I'm going to do the same thing. No chance. It's completely hidden. And that's a big deal, because that's something which is much more long-lasting as an advantage than any other things you can do. Which raises the question, why do we do so much A/B testing on visual things, which are easy to copy, and none on the things which are hard to copy? That's actually a good question. Now, let's go to the end of the keynote part, which focuses on, okay, what is the challenge? Because again, you can say, well, that's great. Google brings all of these good products. I have a good team. They're going to do a usage of it. The future is bright. Well, where things are delicate, and where things are delicate, according to Gartner's in big data project, is to determine how to get value from big data. That's the key problem. Usually that's not the key problem I hear when I speak with my clients. They are very, very afraid about that. And that's a big point, but it doesn't even classify in the first two problems. Because there's many things you can do here, not even at a personalized level. So to think about the challenge of big data, and why, as Gartner says, 85% of the big data projects completely fail, which is a frightening statistics. That's the problem. So what we try to do is to say, well, what is the three main causes of these challenges? The first cause is data engineer overload. We will see why. The second is a dashboard is not an action. Too often, the goal of the project is to create a dashboard. What are you going to do with the dashboard? Okay, well, it will not be paper stacking like this, but it's the equivalent. This will be the virtual equivalent. And big data versus needed data. Your data warehouse is not a junkyard. This is not going to improve the effectiveness of your company by dumping data with the idea that we might need them later. That does not work. Now, a bit more in details on these 3 points. Well, first, if we think about the goal of creating a dashboard, then you have a nice plan for data science, but the reality is quite different. You have data silos, data quality, automation, data visualization, user adoption, and so on. And these obstacles are so numerous if you don't tame them properly that it eats all the time. And that's the scary statistics. That's actually what data scientists spend most of their time doing. Almost 80% of their time is spent in cleaning, organizing, and collecting data. Nothing else. Now, it doesn't take a genius to understand that if there's only a fraction of the time which is available to do the key things we try to do, that limits us a little bit. So that's a real problem, and that's why data engineering overload is not at all a made-up cause. This is actually a completely proven fact by the entire data science community. The problem is how to solve it, of course. Second point is that a dashboard is not an action. When you provide a report, there are a sequence of steps that has to happen late after that, which needs to be planned and which needs to be done effectively, like taking a decision. Taking a decision is not that easy, because it's not only that you have to decide yes or no, you have to decide, okay, how can I use this information and change something in our business? The second thing is, well, then you have to export data, and then you have to integrate it into your website, and then when all of these things are done, then you have to ask yourself, what is the impact? That's a big deal. And the third thing is that the data about online behaviors are completely different than the data which you typically have in a CRM. And that's not understood enough. It's really difficult. There's a lot of fragments of information, a lot of moments of truth, to take back the point of my phone. So that creates a problem. And if you take a click path analysis, what is a click path? It's really easy. You take a list of URLs the user has seen. And if you have gone into Google Analytics, into this behavior flow, that's exactly what you see. So you have a list of URL which represents the journey. And the idea is that by putting a lot of these things together, great things will happen. Well, the problem with that is that there's nothing linear about the customer behavior. And I always like to look with my clients at the specific, completely randomly selected sessions so that they can see what their visitors actually do. They make a search, then they go to the start page, then they put the product in the basket, then they go to something else, and they remove the product from their basket. So some step looks great, others come back. Then when they start to look at products, if they leave after 5 minutes, then it's a problem. But if they stay more than 20 minutes, typically it's not good either, because that means they cannot make a decision, and they're likely not to buy. So is it good that it's long or not long? So this is really, really difficult. And putting a lot of that chaotic stuff together in an unstructured way, yes, it's interesting. I will not lie. As a machine learning person, I'm interested to find patterns in these unstructured data. But as a business, we should be worried about the likeliness of a positive and effective outcome from that part. And one key thing which is missing is that what we look at is extremely important. And not only that, oh, we have seen the start page. No. We scrolled and then we stopped there and we watched that for 5 minutes. And now with the phone, there's not so much display at the same time. Just the scroll and pause gives you fantastic information. But you should not see, and that's why you need structured data. You should not just have, oh, he went pause from pixel 200 to pixel 300, because what good is that for you? No, you need to know exactly in a structured way what was there at that moment. That's exactly the third point. So, to wrap things up, let's go back to this flow that we had before. So, first problem, data engineer overload. Well, we try to solve that with this automated CPU big data generation to remove that problem. Second problem, what to do with the data science reports. Well, we actually built for many years a platform to enact directly outputs that can be generated by the data scientist without involving the IT engineer. Gone. Seen and clicked and experiment results gives you the structured, displayed information you need to have not only a unstructured data analysis, but actually structured analysis of everything people see. And that's why we really believe that we're hitting the nail where it hurts with these approaches. And it's a Boxalino US, of course, we're going to see. But basically, this is not just out of no reason. These really are the weak points of the flow, and this flow is absolutely becoming a reality now. So what is CPU big data? Well, as I said, it's all of these seen and click structured data which are automatically generated for you in BigQuery. It's a lot of reporting templates, which we are building continuously. It's the capacity to load data and predictive models as an upload in our real-time platform without IT involvement. And of course, it's our capacity to provide training and to help data scientists to build their success with all of these new capacities. So that was the 45 minutes of pain. Thank you for enduring. And now I'll show some videos and some visual demos in Data Studio. Thank you.